What's simple? Less than? Awesome. Same letter though, right? Or parameter. Hey, verify requirements. Verify the requirements. Uh-oh. But what did the book say?
Simple random supply and normal.
Yeah, so we can check this all. Yeah, you go, it was only 12. Yeah, but remember what they said? Sample data came from something that's already approximately normal, so we're good. It was a random sample, so we're good there. Now, did this? Let's perform the classical approach. This is where we draw a bell. All right. Whoop. Whoop. I like to remind myself here, Autumn, am I using T or Z?
T.
Because of that. Because it's population means T distribution. Right? Mean Mr. T. Yeah, mean Mr. T. I'm using T, right, everyone? Mean Mr. T. I'm thinking T. I'm going to use the means. I'm going to use this T distribution. Which leads us right to this table. When you get your table, unless you got an inverse T button. Excel has that inverse T thing if you want to use that, Ryan. I feel like Excel does have it, but I just use the table.
Don't you need to do the DS thing? Like
Yeah,
degrees of freedom?
I love it. So where am I shading?
On the left.
I love it. Because of this, we're shading here. How much? Just 1%. How much? Left tail test, they call this. A left tail test. Left tail test. All right. Rocking and rolling. I need to get what's called my critical value. Is it a Z crit or a T crit? It's a T crit. We call it our T crit. Is it going to be positive or negative?
Negative.
So I'm going to get it ready and put a negative symbol because it's on the left side. Does that make sense? Are you sure? Like T equals 0 here. But T is negative on this side. This table doesn't have any negatives on it. Now, how do you read this thing? It's something about the DF. And I didn't even write down DF. What's DF for this?
11.
Right, Mia? They said sample size 12. So I'll put it right here. The DF, degrees of freedom, is 11. 6 donuts? Oh, 5 degrees of freedom, right? So I'm going to look for 11. Is there 11 on this left side? Where are you matching it up with, though?
0.01.
So look to the top. Is it 0.1 or 0.01?
0.01.
All right, look for 0.01 with 11.
2.718.
2.718. Make it negative, though, right, everyone? Now, some people go, I've got a cool new calculator. Well, then you'd have to hit inverse T, 0.01, comma 11 on your calculator. And it'll give it to you. That's if you got, I don't know if you have that, Randy.
Yeah.
Oh, he does. All right, that's what you do. Make sure you put comma and degrees of freedom. We don't have it. My lame calculator doesn't have that cool inverse T button.
-2.7.
Ah, it sounds like we're good then, huh? Our table's just as cool as his new calculator. Hey, when there's something else to finish up the classical approach, we need something called the sample test statistic. All right? I am dropping that yellow chalk. I don't need it anymore. So now I'm going to compare this to something called the sample test statistic. The reason I'm writing this on the board is because sometimes people get these two things confused. I've got the white chalk, right? Where does this number come from? We'll get it from the calculator, but it's coming from these sample measurements, right? Where did this number come from? This number only came from what? This T-crit only emerged from the 1%. Does that make sense? So if you like the color code like me, pen, pencil, cool. It's time for the what? We're going here, right? All right, let's go. Now this time, I'm not going to do any more intervals. This is a test. So I'm looking for a test. But it's not Z's, it's not the proportion stuff, it's a T type of test. So let's find in that group
Number 2.
T test. And Art says number 2. Who comes up quick? Hey, and here, Brianna, I want to show you, remember this was A, this was 8. 10.1 was just intro, but what do I use in 10.3? Number 2. No one see that? Keep us organized. Let's save it. What do we got? Stats? What's this number? 9.02? What was X bar? 8.1? Standard deviation? 0.7? Sample size? A mere 12. Which symbol? Less than, calculate. Awesome. Someone see it? What is it?
Negative 4.55.
I'm gonna have to hit the light so we can put this in the picture. I'm wondering whether or not this is in the critical region.
Yes, it is.
Is it in there?
Mm-hmm.
Do you all agree it's in the critical region? That's that shaded region I did. Is that number in here? We should mark it. Where is that? The bell kept going. It's probably about right here, right? There it is. There's P naught. Let me continue shading with my yellow. Is it in there?
Mm-hmm.
It is. And when this is in here, we reject the null, right? What was that number? Negative 4.55?
Yeah.
I'm just going to leave myself a note. We already know the answer. We're rejecting what? This is what I'm doing with this problem. We're saying, hey, you're out. We've got evidence for what? For this thing. So can we state the conclusion?
Yep.
All right, I'm already going to state my conclusion because I know it. What's my conclusion? I already know it.
There is evidence suggesting that mu is than.
Do you want to be like the author? There is sufficient evidence. There is evidence. Suggesting I always state this. Brianna, I always state this alternative. So there's evidence that mu is less than 9.02 cubic centimeters. Is that cool? But then we're going to do the p-value approach. So how do I get that p-value? Oh, it's on the screen. What was it? Someone see it? Everyone look at this p-value and watch what I write on my board. P-value, this is perform the p-value approach? Okay, do the p-value approach. Well, the first thing is when we do the p-value approach, we report the p-value. Watch what I do. The p-value. Everyone, I'm telling you, I'm probably going to see this on 10 papers on the next test. Look what I wrote. At least 10 pieces of paper will have that.
That's not right.
And T goes, that's not right. I'm telling you, really? I'll have up to 10 students do this. It's probably because it's not highlighted where? Way at the end. See it? It's almost like we wish a bright light shined here. Or like a blinking light showed up. That's not 4.13, that's 4.13
Times.
10 to the negative 4, right? 4.13 times 10 to the negative 4. Now you can write it like that. Some of you write that in decimal form. What is that? With 3 zeros and then that what?
4.
If your p-value is low, reject the ho. If your p-value is low, reject the ho. Is that p-value lower than 1%?
Yeah.
Yeah. That would be extremely unusual.
Another way to
And
consider.
yet we got it, so we're rejecting the null hypothesis. So here comes my interpretation of the p-value.
You are not doing the TCDF thing?
You can if you want. This was a faster way.
That confirms it.
That's exactly what does it. So he does a TCDF and he confirms it. Very good. That would actually confirm it. Very good. All right, I'm going to interpret this. This is the probability. See, a p-value is a what? It's a probability. This is the probability of obtaining these results. And I'll show you what I mean. These statistical results. You go, what do you mean by these statistical results? I'll show you, I'll put it in parentheses. We just found the probability that this x bar, was it greater than or less than? Look at the picture. It was that one, right? We're saying, what was the probability that x bar was less than or equal to that what? 8.1. And here's the most important part when I interpret the p-value. This was all based off what, though? not some magic number where everything was based off this thing. So when I say this, I go, this is a probability of obtaining this, and then I go, if mu is, and this time I'll emphasize that, if mu is really, truly, how much?
9.02 centimeter.
9.02 cubic centimeters. See, it was based off that null hypothesis, right? This is the odds of getting this. But I mean, wouldn't this be kind of unusual in this world? That's extremely rare. That's extremely unusual. So because the p-value is lower than the alpha level, all right, I'll use the yellow chalk. What was alpha? 0.01, what was our p-value? 0.0004. What am I doing with this null
We
hypothesis?
reject.
We reject the hoe with your p-values low. Reject the hoe. Just don't write that. Just don't write that. Y'all are doing awesome.
So, interpret part, we need to write that whole thing.
Yeah. You want to know what's the hardest thing for students? Not just go with Professor Messer across the nation. The students interpreting a p-value. You know, it's not that bad though. You can just go for it. You know, it's based on the results. The key thing about this, when you say it, a p-value, it's a probability, right, of getting these results that we got, right there, or more extreme. We say we're more extreme. That's why I did this less than symbol. Based on what though? So I wrote if, based on if, that's the given value, the given population proportion. And then because what? You look at your p-value versus the alpha level, you compare them. And if your p-value is lower, what do? If your p-value is low, reject the, what if it was greater than? We fail to reject the null hypothesis. We fail to reject the hoe.
So in the conclusion, we state the alternative hypothesis.
Always.
In interpreting the p-value, we state the null.
That's right. That's exactly it. Isn't that cool? Hey, one more thing before you leave. I still want to do a what? Which section? 10.2. The most important thing is, I know you can run through the numbers, is I wanted to make sure right before you leave, if we have time, is set up a bell, right? And I want to make sure you split up that alpha level when it's a two-tail test. Okay? Let me make sure you're okay with that. We don't have to run through all the same stuff and all, but I want to just get that set up. Does that sound good? So, I'll erase this. And in 10.2, this problem was about, you're going to laugh, was about men's strain during marriage. So they did a poll, everyone. First of all, this is according to men's, it's like menstuff.org. They said 22% of men have strayed during marriage. Okay, 22%. Is that a mu or a rho?
Row.
Okay. 0.22. But then they said this. This is in section 10.2. A researcher believes that number has changed since then. Did you hear the wording?
Mm-hmm.
Has changed. Well, it hasn't gone up or down, so it's what?
Not equals.
All right. Well, the level of significance in this problem, I'll tell you the sample they did. They took a sample. The only thing about this, everyone, we're smart. Don't do the checks on this problem, but would you think about this, the bias involved? Can't people lie in a poll? I mean, what if their wife's standing right next to them or they're on the phone? They're like, worried someone's listening. They're like, no, I never did. You know, so that's the only thing about this and this infidelity. That's what they titled this. But here's the sample they got. 122 out of 500 said they strayed at least once during marriage. And we're going to do this problem with an alpha level of 0.05. All right. Oh, do you want the problem number? This was number 24, actually, I was taking from that section. What's so important to me before you left is when you set up your classical approach, we'll hit it on the calculator. When I set this thing up, I make this bell. We're using z because of proportions. How do I deal with this to get my z crib?
Oh, whoops.
both sides.
So do I shade 5% here?
No, 2.5.
What is half of 5%?
0.025.
And all you did was cut this in two, right?
Right.
Does that okay with that? Because of this, what are they doing? They're thinking alpha level divide 2. Now, this isn't a T crit, but it's called a what? How can I get it with that T table? Does anybody know? So you can use inverse norm like Art does. Inverse norm 0.025. But maybe you don't want to do that. If you don't want to do inverse norm 0.025 on your calculator, how can you use that table to find it?
You look at upper tail probability.
Look up at 0.025 at the top, right?
Yep.
We won't look at 0.05 though. What do you get for Z? It's that number comes up over and over and over again. What is it?
4.
So this one's negative, and this one's what? So when, we don't have to write everything down this time, but I want us to concentrate on the p-value. We're in the last button. Perfect time, and this is from 10.2. The button we're looking for is a one prop z-test. One prop z-test. Where is it? It comes up fast. It's not number 2 though. It's number 5. One prop z-test. Okay. Where when you and I are going to concentrate on the p-value, right? If your p-value is low, what are we doing? You go, how low? Well, lower than a 5%. Well, let's see. So I go in here. Here's my one prop z-test. Not interval z-test. Me, I'm going to put the what? The 1, 2, 2 thing they got. This was out of how many people? Whoops. What was the null? They said it was 0.22.
0.22, yeah.
1, 2, 2. This was out of what?
500.
500. What was? Oh, it's a two-tailed test because has changed, right? Lock it. I like calculating. I'm looking at p-value. I want to know the end of the story right now. Am I rejecting the hoe?